Okay, the problem is find the prefix common array of two arrays. What is given to zero index, like array is always zero index. Integer permutation of a and b of length n is given. We will understand what is the meaning of the permutation of it of length n. Okay, a prefix common array of a and b is an array C. Like a prefix common array of a and b is named as C, such that Ci is equal to the count of the numbers that are present at or before index I in both A and B. Okay, we'll see what is the meaning of this. Return the prefix common array of A and B. And what is this permutation of length n? A sequence of n integer is called permutation if contains all the integers from 1 to n exactly once. So array is nothing but length of n, and that is means and it contains from 1 to n. Okay, it could be any order, but it will be exactly once. It should not be possible it could do it more than once, because if array is length n and it should contain from 1 to n all the elements, then obviously it will contain each element exactly once. Okay, so what is given? A and B and the same length, and n is 50. So it doesn't matter, any approach will work. Even if I guess if else like 50 some, how many cases are possible? So that also it is any brute force will work here. And AI and BI is nothing but 1 to n as it said, and it is guaranteed A and B are both permutation of n integers. So that means 1 to n is there. So let's understand what is the meaning of this prefix common array and what will be the output. Okay, let's see two example and we'll understand. So I assume this is the array A and this is the array B. Okay, so we have to say at any ith position, what are the number of common elements in the both array. Okay, so current right now I'm in index 0. So what will be the common position if I only consider index 0? Let's consider this up to this. How many are there? 1 and 2. Like in index in the A, only 1 is present, and in the B of index 0, at index 0, only 2 is present. So nothing is common. So at right now, the common element is 0. Like nothing is common. Okay, okay, great. Let increase the index. Right now, like this, right now I'm in this index. How many will be common at this position? And now if you see, so see, I am drawing this box just for your sake of understanding. You will understand like in this case, how many common elements are there. You can see one is present in array 1, and up to here, one is also present. So up to this index 1, up to this index 1, we have to check what is the common element. So you can see 1 is common, and we can see 2 is also common. So how many common elements there? There 2 elements are common here. So I will add 2 here. Now I will move index my 1 to 2, and if I see here, if I come back here, how many common elements are there? How many common elements are there? So in this case, see, one in up to this index 2, how many elements are common? One is was common earlier. Like earlier, what is common? Now I have to check how many new commons are there. Now you can see 3 is new common. So earlier 2 common is there. Now another element is also common. So that will be 2 plus 1 3. You understand? Okay. Now see, like in the index 3, at index 3, how many elements are common? So the thing is, we can see the earlier how many common elements there. I have to keep track, and after that, but current index position, can I get any new common elements? So earlier it was 3. Can I in the 4 in this index? Can I get any more common elements? Can I like 4? Is it common anywhere? Like it is present in the below case? No, right? 5, is it common? No, right? So earlier what is there? Plus current common. Current common is 0. So it will be 3 plus 0 3. And at the end, how many common elements will be there? So 5 is present here, 4 is present there. So how many common elements? Two common elements. See, 5 is also common, 4 is also common. So two common elements are there. So 3 plus 2, 5. So this is the answer. This is my answer here. So what I have to actually perform this prefix thing, like what is the name is a prefix common array. This prefix common array is saying up to index I, up to index I, any index I, we have to check up to index I how many elements are common in both arrays, that we have to find it out. That is the case. So let's see another example, this one. So currently I am index 0. So index 0, if we in the index 0, how many elements will be common? So this this is not a sliding window problem. I'm using this window, this yellow window, just for your sake, so that you understand easily. So that you understand like up to like what are the elements I should consider to find the common elements. That's the reason, nothing else. It's not a sliding window problem. Okay. So it is a, you can in this position, 0th index, how many elements common? No elements are common, correct? So I will come back to the index 1. So in the index 1, how many elements will you make common? So index 1, you can see 1, is it common? Is it present anywhere? No. 2, is it present? No. 5, is it present? No. 4, is it present? No. So no elements are common, correct? Okay. So okay, let me, here also 0 element is common, here also 0 element is common. So first of all, in the first case you have to say like how many are common. Then we have, next time whenever I go to in this place, we have to check like previously how many are common, plus in this index how many are common, correct? So here also previously 0, and in this index position how many elements are common? 0 elements, so 0 plus 0. Okay, let's increase my, okay, so I will be, I right now I will be at the second index. Okay, I will be at the second index. In this index, how many elements are common? You can see only one elements are common. So earlier it is 0 plus how many elements are common in this index? Three elements. One element is common. One element is common, so it will be 0 plus 1. Next, my I will what? I will be at the third index. This will be my I. So in this element, how many elements are common? So 4, 4 is present anywhere. Yes, 4 is present here. Now I can say 2, 2 is present anywhere. 2 is present here. So two elements are common. So if you notice at any index position, I am actually checking this thing. I am checking only this. Let's say this is my current index position. So I am checking whether this is common. These two elements are present earlier or not. So three, this three is present earlier cases or not. So from here we can understand like we have to store whenever we am getting 1 or 5, any two integer, any two cases. So I have to store that too, so that in the future we don't have to visit and check entire thing like from for this two. I'm obviously I'm not going to check each and every cases, right? I'm not going to check that. For 4, I'm not going to check each and every index. We are not going to check that. So you have to store such a way so that we can simply check once and I will get like without iterating the entire thing. Okay, let's see how could I do that. So anyhow, let's finish this calculation. So at index 3, how many? Two new elements are common. So 4 and 2 two new elements are common. So it will be 1 plus 2, 3. 3. At the last index, at the fourth index, how many elements will be common? How many elements will be common here at the last index? So you can see 5 is common, 5 is present here, and 1 is present here. So another new 2 elements are common. So this will be becomes my 5. So this will be my answer. Like that is the array vector I have to return. So this is what we could do. So as I told you, like at any moment, at any moment, I have to like whenever I'm iterating from one item to another item, like I'm iterating from left to right. Whenever I'm iterating, I have to whatever I got, I have to store that element. I have to store that element, and after that, I have to check whether how many elements are common. So one thing, one brute force could be common. Say I am taking two sets. It's a set 1 and set 2. Whenever I'm index I can put the ith element in the set 1 and the yeah, ith element of A, first array A will be set 1, and ith element of B of the second, that is the second array, in the S2. Then I can do one thing, I can do intersection, S1 intersection S2. Intersection gives me the common element, right? Like what are the common and this in these two sets. So that time I will get. So what I am saying, what we could do, like whenever we are in ith element, let's say this is my I. So I will do two set. I will take two sets, set 1 and set 2. At the ith element, I will add into the set like whatever I. So I is currently 0. What is at the A? What is the item in the ith element? At the this is my A. This is my B. Or this is nums 1, nums 2. Nums1, n1, nums1, and nums2. Okay. So nums1, nothing but nums1 is 1. So I will add into the 1 into it. And what is 5? Nums2 at the 0th index, that is 5. So I will add. Now what is the like what is the common, if I have to find out the common element in two sets, what we could do, it could do a simply intersection, right? So we can do intersection and we find what is the common intersection will be null, nothing is common. So to intersection I will return 0, correct? After that my I will come at the first index. The first index, what is the I will add what? I will, as I told you, like whatever I am coming, I will add into the set and I will calculate. So this is the brute force I am checking. Simple thing. So 2 and 4. So 2 and 4. Then I will do again what? Again set intersection. In the intersection, what can see how many elements are common? Again 0 element. So again I am putting 0. Okay, fine then. In the next case, I will become at the second index. The second index I will add 3, 3. So in right now, how many elements are common? You can see in if you do second intersection, this 3 is common. So this will return me 1. So that is my 1, correct? Okay. So again, my I will be where? I will be at the third index. Third index, if I add into the like, I will add 4 into the set 1 and add 2 into the set 2. How many elements are common? If you notice carefully, this 2, 3 is common, this 2, 3 is common. So how many elements are, sorry, 2, 3 and 4, sorry, 2, 3 and 4 is common, 2, 3 and 4 is common. How many elements are common? 3 elements are common, that is my answer. And at the end, I will be at the fourth index. Fourth index, I will add the fourth index. So I will add the 5 here, and here I will add 1. So if you take carefully, you can see both all the 5 elements are common. So this is the 5 element is common. So this is one approach I could follow. So if I write the code for it, what I have to do? I have to do find prefix function find prefix common prefix common. Let's say nums1 and nums2 are there. So what I am doing, I am taking two sets, set 1 and it is a set, and set 2 also a set. Okay, that is what I am doing. And what I need, I need an answer array. Answer array, it is empty. It is answer array, it is empty. I will add, you can add a vector or something, I will add it into it. So what I will do, I'll iterate through a loop, like for I equals to 0, I less than, I think it's both length is same, so you can take any length. So I'm taking nums1 length, nums1 dot length, and I plus plus. I'll do that. After that, what I will do, I will, as I told you, like I will add into the set. So I'm adding into the set s1 dot add what, nums1 of I. Okay, and in the s2, what I will add, I will add nums2 of I, nums2 of I. Okay, so this is the case. After that, what I have to find it out, what is the uh, common element. So common element is nothing but I can write in this way. Yes, let's say x equals to my length. I have to find the length of it. Okay, so s1 dot intersection, what is the function according to your coding language, please write that. So intersection of s2. and what I need the length. I need the length. What is the how many elements are common? I need the length. How many intersection, like how many common elements are present in two sets? I can find the x and simply append that x into my array. Sorry, not array, answer. Answer dot add x. So that's all. That is what we need. And after that, what we could do? This loop is finished and return the answer. Return my answer. This is what they need, right? So this is what. It is a very brute force. Why I am saying brute force? If you calculate the time complexity and space complexity, you can understand. So what is the time complexity of this problem? Big of n. It is iterating for n times, right? And what is time complexity of this problem? This one. This is also taking, at the worst case, it is taking m plus n time. It is also big of n. As here it is both are size of n, so it will take big of n plus n to n time. So what is the time complexity? Time complexity is big of n square. Big of n square. And space complexity, I am taking two sets, right? So it is big of n. So this is not the optimal solution. Can we find any optimal solution? Let's see. I'm taking this example. This is my approach one. Approach one. Let's see our approach two. Okay. So what we are actually doing, we are taking two set and finding intersection. So instead finding the intersection or elements, can we can't we check manually? What I actually want to see, like we are taking two sets earlier as well, like we are taking two sets, set one and set two, same thing as I did earlier. But right now we will not do intersection. Instead of intersection, can we check one thing? So as I told you earlier, I can add into the intersection. So what I could do, at one I can add in the set one and I can add in the set two. Now I'll check this one, this item one, current item one. Is it present in the set two? If it is present in the set two, that means what? It is appeared in the set two, it is appeared one. That actually we want to find it out, right? That is what we actually find it out, right? So why it is not disappeared? Okay, somehow it got stuck. This okay. So okay, I can write item it is disappearing. I don't know how, but it is somehow it is stuck. So okay, whatever I am saying, okay, let me restart it. I don't know why it is happening. Let me pause and restart. Yeah, it's gone. So I will. So what I actually want to check, I want to check if one, if it is present in the second set, and if two, if it is present in the third set. This is the thing I have to check. Like two should present in the first one and one should present in the second one. This is what we check. And why we are checking the why we are taking set? Set is why, because we are assuming, I will talk it this why we are assuming that to finding one item in the set, it will take big of one time. We are assuming. I will I will comment on that later. But we are assuming finding one item in the set, it will take big of one time. So that's what I am checking. Whenever I am going there, and I have to check whether it is present or not. If it is present, I will count plus plus. Okay. So let's say count is 0. Let's say one count I need, count is 0. So at the end, I will add up at the end, after I check two cases, this first item and second item, this will be my answer. This current count will be answer. See, count cannot be increased, sorry, decreased. Count always will be increased. Like common element will always increase. It will never decrease. Oh, that's the reason. So let's see answer. My answer is right now C1. One I will add it in the set one. Two I have added in the set two. Now I'm checking is there like now set two. Now I have to check is one is present here or is two is present in this case. So nothing is present. So count will be 0. So for this index my answer is 0. Second element I will add 2 in the first index, 3 in the second set. Okay. So if I add that 2 in the first, and 2 in, see, I am adding first then checking. So later you will see it will be create a problem. So we will see whenever it creates a problem. So 2 is added. So we will check 2. 2 I will check in the second set. It is present. Yes, it is present. 2 is present. So I'll increase the count. Count becomes 1. Okay. Now now I have to check 1. 1 I have to check in set 1. Like whatever. Like if I am taking item from set 1, I have to check in the set 2. If I am taking item in the set 2, I have to check in the set 1. This is what to do. So if I sorry, I told you wrong. If I checking item from array 1, I have to take a check in the set 2. If I am taking item from the array 2, I have to check in the set 1. This is what I have to check. So see here 2 is already present in this case. So I will increase the count. 1 is also present in, I have to check in this one, check in the one in the set 1. So if 1 is already present, 1 is already present. If it is present, then I will also increase the count. So my idea is simple. I will just whenever I got a count, I'll increase the count. Whenever I got a match, I will increase the count. So this count is also present there. So this becomes 2. This is my count. Okay. Now 3. In the case of 3, what I told you, whenever I'm coming to the new index, index 2, and in this case I will add item from the first array in the set 1, item to the second array in the set 2. So let me add 3, 3. Okay. So in this case, after adding, I am checking whether 3 is present in the second set. Yes, 3 is present in the second set. So I am counting by 3. Okay. Now again, condition is like again 3 I have to check. 3 is check. 3 is in the first case. See here, this should like now 3 I am checking from here, and if I am checking whether it is present in the set 1. Yeah, it is also present. So again, by default, according to my logic, whenever I found that element, I will increase the count. Now check this thing. For 3, I have counted twice. I have counted twice. It becomes 4. But the actual thing is, I should not count 3 twice. The 3, both of them are belongs to only one. Like how many unique common number of items present, right? So 3 should count as a 1, but I am doing uh, counting twice. So there are two ways we can skip this. If I check if a equals to b, sorry, a of I equals to b of I, or nums of I equals to nums 2 of I, nums of 1 of I equals to nums 2 of I. If that are case, I will not check the second case. I'll check only the first case. This is the only one case I can do. In the second case, what I could do, I could, like, first I will check whether it is present, then I will add. First I will check whether it is present, then I will add. Let's start from the beginning and you understand what I'm saying. So earlier count is 0. My currently I am at 1. I am at first place. So I will check first, like, is my 1 is present in the second set? Is it present? No, not present. I will write after that I will add 1. Now I will check about 2. If my 2 present in the first set, no, so I will add 2 in the second set. Okay. Now my I becomes here. Now nums 1 of I, this that is 2. Is it present in the second set? Yes, this is in the present in the second set. So I increase the count becomes 1. And after checking, I will add it. So I will add this 2 in the where I should add. I should add into the first, because these 2 becomes the first array, nums 1 array. So I'll add 2 here. Now I will check 1. Now 1 I will check in the first set, because it is belongs to the array 2, nums 2. So is it present in the first? Yes, it is present in the first. So count becomes 2. So count becomes 2, and add this one into the second array. Good. So what is the answer? I forgot to write the answer. This is 0 and this will be count is 2. Now I becomes at the third index. Now see how this thing affect. So 3, if I check 3, is it present in the second set? No, it is not present in the second set. So count will not increase, but I will add this 3 into the set 1. Now I am checking the 3 here. Now by default it is skipping the first case, but see here, whenever checking the 3 in the second case, see it is present. present in the set 1. So that time my count will increase and it becomes 3, and I will add these 3 into the second set. So this is how it works. So it count become 3. So right now I am not calculating the 3 twice. And this is how we could skip. Now let's finish our calculation. Now my I becomes the third position. This 4. 4 I have to check. Correct. 4 I have to check. 4 is it present in the where? Is it present in the second array? No, it's not present. I'll add into the first array. And 5, let's see 5. 5 is it present in the first array? No, 5 not present in the first array. So I'll add into the second array because 5 belongs to the second array. So after that, I becomes what? I becomes, and what will be the count? Count will be the same. So I have to put the count as 3, same count. So I becomes 4. So nums1 of I becomes 5. Is 5 in the present in the second array? Yes, it is present. Count becomes 4 plus 1. And I will add that 5 into the set 1. And this is what about 4? Second, like nums2 of I. Is it present in the first array? Yes, it is present in the first array. So I will increase the count and include the this 4 into the second set. 4. And what will be the answer after adding everything, checking and adding? It will be the current count. So it will be fine. So this is my answer. So this is how we could solve this problem. So hope you getting it. So what I am saying, so again let me copy this first. So this is my function. What I have to do, I am taking two sets again, so set and answer, these are also common, and also we have to iterate for each item. So these 3 lines are common, 4 lines are common. Directly copy and paste it here, like nothing but set 1 and set. Okay. Now the thing is, what I am checking, if my item a of item I, or sorry, not a of item, nums of item, nums1 of I, is it present in the second set, right? So how could we check, how could we write that thing? So in the pseudocode, how could I write? I can say, okay, s2 dot find, I'm assuming you return true or false case. So if in the set 2 I'm finding this case, if it is present, let's say find returns true or false. If it is present, then I will do what? I will do count plus. So for that I need a count variable as well. I need a count variable, cnt equals to 0. So if that is the case, I'll do count plus plus. I got it. After that, what I have to do? I have to, in the AS1, I will add nums of I, correct? I'll add nums of I, and after the same condition, I will check for S2, S2. In the S2, I have to check if in the AS1, can we find nums2 of I? In the AS1, can I find nums2 of I? If that is the case, I'll count again, count plus plus, and add as of 2 dot add my nums2 of I, nums2 of I, nums2 of I, this is nums1 of I, nums2 of I have to add that. After that, what I have to do? I have to, like, this count is my current answer. This index position, this count is the correct answer. So I have to add that into the answer. So answer dot add, my current count, correct? So my loops end, and I will at the end return return my answer array, and here also my function ends. So if I calculate the space complexity and time complexity, time complexity is nothing but this is big of n, big of n, and I am considering this is big of 1, considering, please remember this, I will come here later, but I am considering this big of 1. So time complexity is big O of n, and space complexity I'm using an extra set, so I'm not calculating this answer case because it is I need that right to return, so I'm not considering this answer, but I'm using two sets, so that's why it is big of n. So time complexity is big of n, and space complexity is also big of n. So here we are using two sets. So can we reduce to the one set? Can we reduce this answer to the one set? See, and I check that. Let's check. So that's come our approach 3. Our approach 3. So here is my our set. So instead of two set, can I check into the set one? See, the thing is, I will use the same problem, but I will check in this only single set. See, anyhow, if it is seen already, if one is seen, so this one I am checking in the set 2, and 2 I am checking in the set 1. So both are seen, like earlier 1 is also seen, 2 is also seen. So can't I combine those two in a single set? Can't I combine? So let's try adding into the single set. Let's see what happens. So but checking will be the same, like here I was checking in the 1. So set 1. So this earlier it was checking s1, this nums 1. Whenever items belongs to nums 1, I'm checking the set 2. Whenever nums item belongs to nums 2, I'm checking the set 1. But the thing is, at the end, both are having the, like, 1 is also seen. What I was doing that time, let's show you. This is s1, and let's say it is s2. What I am doing, I'm writing. So 1 is not present, I am adding here 2 here. The next time 2 I am saying checking in this set 2, and 1 I'm checking in this set 1. But the thing is, this 1 and 2 are visible. 1 and 2 is checked, so I can add this 1 and 2 in the same set. I can add this 1 and 2, like say only one set, and check 1 and 2 is there. So if see what, how could I say this 1 and 2? Because see, if 2 is present in the set, so if it is, I am currently at the this index, and index my nums1, nums1 is nothing but nums1 of I is 2. That means this 2, whatever this 2 is there, whatever this 2 is there, it is not coming belongs to me, it belongs to my set 2, and it is already visited. So we can directly check in the common set and 2 here. So I can check this 2 is already there or not. If it's already there, that means what? It was visited by, it is added by from the nums of 2. That's why it is present there. Otherwise, there is no possibility it will be added in this case. So that's why it is present. So similarly, 1, in the 1, if I check, currently I am in the 1, and 1 is also present in the set. So I am currently 1. I didn't contribute 1 into the set, but who has contributed in 1 into the set? That obviously it should be the other array, not me. The same thing. Okay. Hope you are getting it. Let's do the diagram, then it will be more understandable, I guess. Think this is the set. This is the set. So currently, which index I am? Zeroth index. Zeroth index. I will check what, whether nums1 of I, is it present in the set 1? No, right? I will add it, and count also I need. Earlier 0. This 2, is it present? No. So I will add into the 2. So what will be the count? Count will be my current count. So 0. So now I will check that 2. This 2, is it present in my set? Yes, it is present. It is present means it is contributed by what? I am currently. So this is a one thing, is like each element is appearing once. So that is one advantage. So it is not kind of contributed by me. So it is must be contributed by set 2. So other array. think of not set1, set2, think contributed by, sorry, not think of array1, array2, nums1, nums2. This is by contributed by other array. Think of it. So it will, this 2 will be contributed by other array. So that is actually one, like it is present in the other array or not. So that's why I am saying, okay, it's present. That means, okay, count becomes 1. And this, after that, I'll check this one. Is it present? Yes, this is also present. So count becomes 2. Now think, it is a set. Even though I add it, I don't add it, doesn't matter. Because set will only store the unique items, right? So it doesn't matter if I add it or not. Okay. Now 3. 3 is it present in the set? No, right? So count will be not increased, so 3 will be added. Correct. So next time I'm checking again 3. So as I becomes here, comes here. So that 3 right now, I this 3 is added by the first element. 3 is added by the first array. So that time it is not present, but it is added. But right now, if I checking this 3, is it present? Now say 3 is also there. So I'll increase the count, and 3 becomes what? 3 becomes, I'll not add 3. So if I add, it will become same. So, okay, I forgot to count here. So it will be 2. And how many counts are there in this one? 3. 3 counts are there. Now I'll check 4. So 4, is it present? No. I will add the 4. Count will not increase. 5, is it present? No, 5 is not present. So add the 5, but don't no increase the count. So what is the count? Count is 3. So it will be same as a 5. 5, what is there? 5, is it present? Yes, 5 it is present. So increase the count. Add the 5, doesn't add 5, doesn't matter. Then I'll check 4. 4, is it present? Yes, 4 it is present. So it becomes 5. So count increase 5, add 4, don't add 4, your choice. So it becomes, what is the count? Count is becomes 5. So this is the answer. This is how we are checking. I hope you are getting it. So I'm taking the entire thing. See, because most of the thing are equal, I'll check. I'm just saving the time because my videos are too lengthy. That's why I try to save the time. So this is the case. Earlier I need 2 sets, right? Earlier I need 2 sets. Right now I need only 1 set. So set S is fine, is sufficient for me. So after that, same thing. And the count is required, answer is required. I can't comment on that. After that, I have to also check if I was checking if it is find present in the S, not S2 or anywhere. If it is present in the S, then I will add into the S. So even though it is not present or present, adding the item doesn't matter. Adding the item doesn't matter because at the end it is set, as I told earlier. So this is the same thing. So this is the same thing, and here also it will be the same. Like instead of S1, I have to check in the S, only S. This S at the end, I will also add, but not in S2. I can add in the S, and the only one S. So I have the answers. Exactly same code. Nothing is different. Nothing has been changed, and this is what. So what is the time complexity? Nothing is changed. Nothing. This is also big of A. This is also big of 1. I am considering. So this is big of N. So and everything I'm considering as a constant item. So time complexity is nothing but big of N. Space complexity, I'm using an extra space as a set, so it will be big of N as well. Okay, it is exactly same. Earlier I was using 2 set, right now I'm using only single set. Okay, now comes one thing. Every time I'm saying this thing is considered as a big of 1, I'm assuming, but this is not always the case. In the set or hash map, everything it can take, if it is too large, it can take big O of log n time to find the element, not big O of 1. In that, the big O of n means the number of items present in the hash set or hash map. So that could take, it is not actually big O of n. If it is a host case, it could take n log n time. It is varies hashing algorithm from one language to another language. So this is actually I'm saying it, but it could go to in log n time. In log n time, it could go. So it is not actually big of n, it is approximately big of n. Please remember, it is approximately big of n. In the interview or something, you have to say this kind of thing, like it is possible, like it goes to log n time. This function, this can take big of log n time. So it is a worst case. So it will take big of n log n time. So right now I have my target is to do exactly big of n time complexity. Okay. So how could I do that? So that is the best case if my size is limited or something, like kind of we can use array. We can use array indexing. We can directly search, and array indexing we can, it is always big of one time because it is already fixed. The trade-off is there. This space complexity is constant. It is take big of 1 to big of n in the set case, right? It could be varies, it could vary, but the thing is, array, it is always I have to always have a constant space. So that is always a trade-off between time and space. If you want to save the time, you have to allocate more space. If you want to save the space, it will take more time. There is always a trade-off between time complexity and space complexity. So what I am going to use, I am using the array. Let's see how could we solve using the array. Copy. This is my approach 3. Approach 4, I guess. How many I have done? Is 2, 3, yeah, approach 4. Fourth approach. Okay, how could I solve this in a array? So earlier I am using set. Now I will use an array. So I will use an frequency array. I'll use a frequency array. So let's say frequency f, and I'll allocate to how much items are there, 0 to n. So I'm allocating n plus 1 items. Why n plus 1? I always know my what is the item. Item start to 1 to n. So that's why I'll never get a 0. So it will be kind of extra space, and it doesn't matter because I'm taking only one extra array space. Just only one set extra. Doesn't care. So this is what I will consider n plus 1. So n is what? 5. So if I take 5, so it will be 0 to 4, but I need also 5. So that's why easy. For that case, I'm taking 0 n plus 1. So 6 items, that so that it becomes 0 to 5. Now earlier this count will store as 0. Everything will store as a 0. Okay, fine that. Now if everything is stored as 0, now what are the cases? So what we have to check? So what we have to check is, like when I can say, like if when I can say this any item is present in both cases. So it is only the case if any count is becomes 2. That means it is present in the both cases. Let me show you how. See, currently I am I am at the 0th index. Okay, so right now I cannot check, like in the set I am directly checking in the set it is present or not. Now I can't check. I will have to check, like what is the count of 1. Count of 1 is 0, but it is appearing once, right? So first it is, right now it is appearing once. So I will increase the count first. I'll increase the count. Our count becomes 1, and whenever it hits 2, that time it is already present. That time it is present. So that's why count becomes 1. But and also I have to check here also count. What is the count of 2? This is 2. So this 0. So I will increase the count and check whether it becomes 2 or not. So there is a confusion, like should I increase the count first, or should I check, like after I checking can I increase the count? There is also a confusion. Let's take both cases. So for right now I'm increasing, like checking first, then I'm increasing the count. Checking first, then I'm increasing the count. Okay. If I do that, so for initially everything is 0. So 0 I'm making is empty. Consider this empty space is 0. Okay, so first I am checking, like it is what 2 or not. So 1 is 1. I am checking what is the count of 1. So count of 1 is right now what, 0. So So whenever it becomes hit 2, that means it is present. So count of 1 is what? Okay, CNT count 1 CNT. This is my current count is 0. This is the count of the uh, number of item present in the both arrays. So right now 1 is not there, it is 0. So it is not 2. So that's why I'm increasing the count to 1. Similarly, for second case also, count is 0, not 2. So I becomes 1. Next case, this 2, is it 1? Yeah, it is 1. So if, see, I am checking the count first, if it is 2 or not, then I am increasing the count. But if it is I am doing that, then I am wrong, because 2 here, 2 should count 2 at this moment, but if I check the count is 2 earlier, then it becomes 1. So after it becomes 1, then it becomes 2. So again I need to check like whether this 2 is count is 2 or not, because count is 2 means it is appearing here, and earlier it was appearing also. So that time it should becomes 2, and then I check like whether count is 2 or not. If count is 2, it is appearing earlier and right now. So that's why I increase the count first, then I should check. Okay, let's do from the beginning again. So index it at the 0th index. I am increasing the count of 1. So count of 1 becomes 1, and count of 2 becomes also 1. Nothing is there, so index comes here. I'm increasing, what is the 2, item is 2, so I'm increasing the count of 2, so it becomes 1 to 2. 2 means it is already present, 2 means it is there. So this count becomes 1. Okay, because 2 present earlier and right now as well, so 2 becomes 2. And here in this 1 also becomes 1, 2. So that's why count becomes 2. So earlier count was, answer is 0, now count is 2. Now there is a special case. Special case is the third index. 3 count is 1. So 3 count is 1. So earlier it is 0. So it will be increased by 1. It will be increased by 1. Correct. It will be increased by 1. After that, this 3 comes here again. So 3 comes here again. So I'll increase the count. Again, increase the count. It becomes 2. And I'll check this 2 or not. 2 is there. So right now count becomes 3, because again it becomes 2, number of it is 2, count is 2, so it becomes this count becomes 3. So I should have said frequency. Okay, so it array comes here, third index. The frequency of 4, what frequency 4 was 0, so I increase 0 to 1, and frequency of 5 also 0 to 1. So count is not, frequency is not 2, so that's why I'm not increasing the thing. So count becomes 3, and this will be my answer. This is 3 also, this is 3 also. Now I comes this place. Frequency of 5 was, I have to increase the 5, it becomes 2. Okay, frequency increase, so I have to increase the count. So count becomes 4. And coming here, 4, I have to increase the frequency of 4. It also becomes 2. So it becomes 2, that equal becomes 5. Okay, as easy as that. So I will use the same condition, same function. But condition will be slightly different. The same function, but conditions are different. Okay, so I'm taking another array, let's say frequency. It is nothing but of size of what, size of n, array of size of n plus 1, length of nums. Okay, let's say length of nums, size of nums 1 dot length plus 1. This is that size of array, and initializing at 0, initializing everything as 0. So right now if you are checking, so right now earlier I have to do what, I have to first increase the count, then check if his count becomes 2 or not. Okay, so I'll do what, I will do what, frequency of what, nums of I, nums1 of I have to increase the frequency plus plus. Now I have to check if if my frequency of nums1 of I is equals to 2. That means what? Seen this case earlier. That means count plus plus. Okay. And after that, I have to do what? Again, I have to check the frequency, like frequency of nums of 2 of j, sorry, not j, I, nums of 2 of I have to increase. And again, I have to do what? I have to check again, like if frequency of nums of 2 nums 2 of I equals to 2 or not. If it is 2, then again I have to do count plus plus, and at the end I will add the count into the my answer. This is the case. So this is what, now see, this is the time complexity. This is big of n, and this is obviously big of n. Obviously big of n. Big of, sorry, 1. Big of 1. The time complexity is strictly is big of n, and space complexity I am taking extra array for this frequency is also big of n. So earlier in the set case, it could be big of n to big of n log n based on the time complexity of accessing the set item. So this is the difference. So this is the most optimal approach. Okay. Hope you understand the concept. I know video is very long. Sorry for that. And as always, if you find any mistake in this video, please comment it down so that I will rectify the mistake. And if you find any useful information on this topic, please also let me know so I can also learn. Thank you. Bye bye.